Hello. We'll continue with the chapter variable acceleration. In the last lecture we studied that if acceleration is varying, then it may be given as function of time, it may be given as function of position, it may be given as function of velocity. In the last lecture we studied if acceleration is given as function of time t, replace it by dv by dt and integrate it for other equations of motion. If particle is given as function of position, then replace acceleration by v dv by dx and integrate it for other required equations of motion. And if acceleration is given as function of velocity, then replace acceleration by dv by dt for velocity time equation and replace acceleration by v dv by dx for velocity position equation. Okay. Also in the last lecture I told you that generally, not necessarily always, but generally motion is defined using acceleration. But read this problem. A particle is moving along a straight line. The motion of the particle is governed by the relation v is equal to 4t squared minus 3t minus 1 meters per second. So here velocity time relation is given. So if velocity time relation is given, how to get other equations of motion? Simple. dv by dt, differentiate with time and you will get acceleration time relation, and integrate velocity, replace velocity by dx by dt and integrate, and you will get position time relation. Simple. So what is very important to understand here, when you are not sure or when acceleration is not uniform, then to get other equations of motion, you should use differentiation integration. You should use basic definition of velocity acceleration. Velocity is dx by dt, acceleration is dv by dt. Okay. If position x is minus 4 meter at t equal to 0, determine position and acceleration x and a at t equal to 3 seconds. Find also the distance travelled by the particle in first 3 seconds. Distance travelled by the particle in first 3 seconds means from t equal to 0 to t equal to 3. First we should write necessary equations of motion. In the sense, velocity time equation is given. Now you require position time equation and you require acceleration time equation. So let's write those equations first. So this is given equation of motion. V is equal to 4t squared minus 3t minus 1 meters per second. Replace v by dx by dt. Otherwise it's equation 1 once again written here, replacing v by dx by dt. Separate the variables, integrate, simple integration, 4t cube by 3 minus 3t squared by 2 minus 1t, that is x raised to n plus 1 by n plus 1, standard formula, and this is how you get x. To evaluate this constant of integration, what information we have? X is minus 4 meter at t equal to 0. So at t equal to 0, x is minus 4 meter. So put in equation 1 and you got value of c as minus 4. So put c equal to minus 4 in this equation so that you will get correct equation for position time. This equation gives you position at any particular time instant. We are also asked to find acceleration. So acceleration time relation, just differentiate, dv by dt is acceleration. So differentiate equation 1. Differentiate equation 1 with respect to time t and you got acceleration. This is dv by dt. This is third equation of motion. So these are the equations of motion where all 4 variables are involved in these 3 equations: acceleration, velocity, position and time. Now whatever asked in the problem about motion of the particle, you will able to answer. Now what is asked in the problem? Position and acceleration at t equal to 3 seconds. Simple. Put t equal to 3 seconds in equation 2, you will get position. Put t equal to 3 seconds in equation 3, you will get acceleration. and you got position 15.5 meter. Position is vector quantity. Don't forget we have got positive answer. And acceleration is 21 meters per second squared. When you get positive answer, it means direction is known. Okay. So this is how you can write the answer. Now, what else is asked? Find also the distance travelled by the particle in first 3 seconds. You are asked distance travelled. Distance travelled. This is very important. Position, displacement and distance travelled are 3 different concepts. Position is answer to the question where. Where is particle at certain time instant? That you get from this equation 2. Displacement is change in position. That is what you have studied in school level also. Displacement is change in position. And try to understand. If particle does not change its direction of motion, then distance travelled is equal to magnitude of displacement. But if particle changes its direction of motion, then distance travelled is greater than magnitude of displacement. So therefore, to find distance travelled, remember in this problem you are studying how to find distance travelled. Remember, to find distance travelled in particular time duration, you will have to check whether particle changes its direction of motion in that duration. Now, how to check whether particle changes its direction of motion? You have studied it earlier. Just put v equal to 0. During motion, when particle changes its direction of motion, its velocity becomes 0 momentarily. So check whether particle changes its direction of motion in first 3 seconds. First 3 seconds means from t equal to 0 to t equal to 3 seconds. So put v equal to 0 in equation 1. You will get a quadratic equation. Now when it is quadratic equation, remember, when it is quadratic equation, cubic equation, don't use alpha key of your calculator to find that unknown. Instead, properly get 2 answers for quadratic equation and 3 roots for cubic equation. In this case, you will get these 2 answers. Now there is nothing like negative time. Time measurement starts from t equal to 0 onwards. So discard negative answer for time. So at t equal to 1 seconds, what you have realized, listen, at t equal to 1 seconds, velocity is 0. So that means you have realized here that particle changes its direction of motion at t equal to 1 seconds. So in this duration, that is in first 3 seconds, that is from t equal to 0 to t equal to 3 seconds, in this duration, at t equal to 1 second, particle has changed its direction of motion. That means from t equal to 0 to t equal to 1 second. Particle moves in a direction of motion, and whatever it is, at t equal to 1 second, particle changes its direction of motion and starts moving in opposite direction. So in this case, divide this time duration. Listen, try to understand. If particle moves 2 meters rightwards and 3 meters leftwards, what is total distance travelled? 5 meters. Exactly the same logic we are going to use. This time duration we are going to divide in 2 parts, t equal to 0 to t equal to 1. Why? Because at 1 particle changes its direction of motion, and after t equal to 1 particle starts moving in opposite direction. So then t equal to 1 to t equal to 3 seconds, that is second part of this duration. We will find displacements in these 2 portions of this duration. Check here. Displacement from t equal to 0 to t equal to 1 seconds. It is x at t equal to 1 second minus x at t equal to 0, that is final position minus initial position. Basic definition of displacement, change in position. Now this equation 2 will give you position at any particular time instant. So put t equal to 1 seconds in equation 2, so that you will get position at t equal to 1 second, and put t equal to 0 in equation 2 and you will get position at t equal to 0. So get those values. At t equal to 1, position is minus 5.17, at t equal to 0, position is minus 4. That is already given, and if you put t equal to 0 here, you will get the same answer. Okay. So displacement from t equal to 0 to t equal to 1 seconds is minus 1.17 meters. That means this particle in first second, 0 to 1 second, it moves 1.17 meters in negative direction. Now remaining part of this duration, that is from t equal to 1 to t equal to 3 seconds, we'll find now displacement. So x at t equal to 3 minus x at t equal to 1, final position minus initial position. This final initial, that is for this duration. Here initial means t equal to 1 and final means t equal to 3 seconds. Now get value of x at t equal to 3 seconds and x at t equal to 1 second using equation 2. So displacement from t equal to 1 seconds to t equal to 3 seconds is 15.5 meters minus 5.17, and that is 20.67 meters. So 0 to 1 second particle moves in negative direction, from 1 to 3 seconds particle moves in positive direction. So what is total distance traveled? So just add magnitudes, don't consider this negative sign. It's like that example I gave you, particle moves 2 meters leftwards and 3 meters rightwards. So what is total distance traveled? 5. So only add magnitude. So here by adding magnitudes, that is 1.17 meter and 20.67 meters, distance traveled now you will get, and it is 21.84 meters. So in this total duration 0 to 3 seconds, distance traveled is 21.84 meters. Now read this problem. A particle is moving along a straight line. The motion of the particle is governed by the relation x is equal to t cube minus 9t squared minus 75 meters. So here position time relation is given. Simple. dx by dt velocity, you will get velocity time relation. dv by dt is acceleration, you will get acceleration time relation. So getting the required remaining equations of motion, that's not at all a problem. Check what is asked in the problem. Determine average velocity and average speed in first 10 seconds. Now listen, first 10 seconds means from t equal to 0 to t equal to 10 seconds. In this duration, t equal to 0 to t equal to 10 seconds, average velocity. How to find average velocity? Displacement divided by duration. That is average velocity. And how to find average speed? Distance traveled divided by duration. So duration is already known, 10 seconds. Now in this 10 seconds, that is first 10 seconds, we should find displacement and also distance traveled. Now here you will understand it better. First of all, get the corresponding equations of motion. Given equation of motion is x t cube minus 9t squared minus 75 meters. So differentiating x, dx by dt, and differentiating velocity, acceleration. So we got the three equations of motion. Actually in this problem, you are asked velocity and speed, and to find average velocity and average speed, you should find displacement and distance traveled. Okay, here this third equation was not required, because average velocity, what is asked in the problem? Average velocity and average speed. Average velocity is total displacement in that duration divided by the time duration, and average speed is total distance traveled in that duration divided by time duration. So basically you want to know displacement and distance traveled in those 10 seconds. Acceleration is not asked in this problem, but just to make you understand that how we can create relations or necessary equations of motion, I have written this equation here, but that was not required in this problem. Displacement is change in position. So displacement in first 10 seconds, that is t equal to 0 to t equal to 10 seconds. It is x at t equal to 10 seconds minus x at t equal to 0. So from t equal to 0 to t equal to 10 seconds, this is how you will get displacement. Just put values of t, 10 and 0 in equation 1. So you will get these answers. And 100 meters, it is positive answer. That is displacement is in the positive direction in this entire duration. This is total displacement in this duration. Final position and initial position. Change in position is displacement. Average velocity now we can find. Displacement by time duration. So average velocity is 100 divided by 10, that is 10 meters per second. This is average velocity. It is positive answer. Remember, we are not just writing magnitude, direction is associated with this. since it is average velocity, it is vector quantity, here no any sign used, matlab it is understood that it is positive. Now we are also asked to find average speed. Average speed is distance travelled divided by the time duration. Remember, if particle does not change its direction of motion in these 10 seconds, then distance travelled is equal to displacement. So in that case, distance travelled also you will get 100 meters. But we don't know right now. We'll have to check. Remember now, when you want to know distance travelled, you will have to check whether particle changes its direction of motion. And how to check it? Put v equal to 0 in equation of motion. So here the second equation is equation of motion for velocity. So put v equal to 0 and get the answer. So this is how there are two answers, t equal to 0 and t equal to 6 seconds. At t equal to 0 means when motion starts, velocity is 0. Okay. But once motion starts, when particle changes its direction of motion at t equal to 6 seconds. That means from t equal to 0 to t equal to 10 seconds, in this interval at t equal to 6 seconds, particle changes its direction of motion. At t equal to 6 seconds, velocity again becomes 0. Means particle changes its direction of motion at t equal to 6 seconds. So now, like the method we used in the last problem to find distance travelled, same thing here. Total duration is 0 to 10. Divide this duration in two parts, 0 to 6 and 6 to 10, and find displacement in these two parts of this duration separately. So that is what we'll do. Displacement from t equal to 0 to t equal to 6, that is x at t equal to 6 minus x at t equal to 0, and displacement from t equal to 0 to t equal to 6, therefore you will get just values of x at corresponding time duration. It is minus 108 meters. What do you mean by this negative sign? Particle moves in the negative direction. So if it is horizontal motion, you can say that particle moves 108 meters leftwards. Okay, but we want to know distance travelled in 0 to 10 seconds. So we have divided this interval in two parts, 0 to 6 and 6 to 10 seconds. From t equal to 6 seconds to t equal to 10 seconds. So what is that displacement? Change in position. So in this interval, final position minus initial position, put these values of time instants in equation 1 to get corresponding values of x. So at x t equal to 10 seconds, 25, and x at t equal to 6 seconds, minus 183. And this is a displacement positive. So what does that mean? From t equal to 0 to t equal to 6 seconds, particle moves in negative direction. At t equal to 6 seconds, particle changes its direction of motion, and from t equal to 6 seconds to t equal to 10 seconds, particle moves in the positive direction 208 meters, 208 meters. If you add these two values considering negative sign, you will get total displacement. How much is that? Exactly 100 meters. That is what we have already found out. But we want to know distance travelled. So particle moves 108 meters in the negative direction, 208 meters in the positive direction. Add only magnitudes and you will get total distance travelled. So total distance travelled is 316 meters. And therefore, average speed is 31.6 meters per second. Speed is distance travelled by time duration, that is average speed, and we got the answer. Now listen, lecture 1 on variable acceleration and lecture 2 on variable acceleration. After listening to these two lectures, after watching these two video lectures, read solved problems. I have given you a question set, read solved problems from those question sets. Thank you.